On to our speaker. In this session of Data Hour, we have Seth Levine with us. Seth Levine is a seasoned data scientist, ML researcher, and entrepreneur with a passion for advancing AI, particularly in NLP applications. With a wealth of experience in the field, Seth brings invaluable insights into leveraging AI for customers, service optimization. Seth is also the host of the Learning from Machine Learning podcast. Thanks for your patience. Now over to you, Seth. The virtual stage is all yours.
All right, great. Thank you so much for having me. I'll pull up my slides and we'll get right into it. Okay, thank you so much for this great opportunity. I've been watching Data Hour for a couple of years now, so it's really a pleasure to be on the other side. Analytics Vidhya really provides great resources. I always find myself on there somehow. So today, yeah, harnessing machine learning and natural language processing for elevated customer experiences. Before we jump in, I just wanted to give a little bit of background about myself. So yeah, my current position, I'm the lead machine learning scientist at Loris. I'm going to get more into Loris and what it is, but I joined about 5 years ago. I'm the creator and host of Learning from Machine Learning, which is a podcast that I launched in the beginning of 2023. And I'll be mentioning some of the people that I had as guests throughout because the tools that I use are some of the people that I've spoken with. I have my master's in computer science and a bachelor of applied science from the University of Pennsylvania in complex human behavior and evolution. It was an individualized major, and I really got to explore my interests in the overlap of human intelligence and artificial intelligence. My career experience, I've worked in many different roles. I've been designing websites since I was a kid. I created the website for my elementary school. I've been involved in a few startups. I've worked as a ML researcher doing some computer vision and signal processing, and I worked as an NLP consultant as well. Basically, I'm driven by solving hard problems. I've always enjoyed doing that. And my dream, it was like very idealistic. It was to work with a smart group of people on hard, interesting problems. And that's what I get to do at Loris every day. I'm inspired by the people that I work with, and being part of a startup is very special. You get to do things that are different and disruptive, and you challenge the norms and get to blaze your own trail. Today, these are some of the things that we're going to do and go over. First off, what is Loris? What are the NLP and ML challenges that we face? Topic modeling using BERTopic. Specifically, how can topic modeling be used to support supervised learning? I'll talk a little bit about data annotation and how we use Argilla. Few-shot text classification using SetFit. I'll go over evaluation, maybe touch a little bit on thresholding. I have a demo, which is really a walkthrough of 2 notebooks that I worked on. And then we'll wrap up and we'll have a Q&A. So what is Loris? So actually, Loris is an animal. They're actually the only known venomous primate, and they have a toxic bite. So you might ask yourself, why would you ever name a company Loris? It's because if you don't get customer service right, it's like a poison, and that will slowly kill your brand and kill your company. So Loris focuses on helping companies get their customer service right by offering conversation intelligence and analytics. We've been around since 2018. We have incredible clients, just listing a few here: Bill, Slice, Fiverr, Mint, BarkBox, Calendly, across many different industries. We actually also started working with BPOs, so that those are companies that help other companies with their processes like customer service. We're across multiple countries. We're on 6 continents. We have tens of thousands of users. Yeah, I mentioned here we have some great investors. And I touched upon it before, but yeah, I joined Loris back in 2019. So I've been working in this space for a bit now. And we were a team of about 5 then. And now we're about 40 plus. So I've watched this company grow, our processes change, and I've watched us go from, doing anything to get that first client to now, dozens of clients. So you always have to start off with the problem. In customer service for companies, really in general, there's this underutilized resource, the conversations between their customers and their agents. It's basically a raw, untapped resource. It could be their biggest asset. And currently, there's not really that many ways of leveraging it. It is a gold mine of data, but it's a mine. It's a raw resource. It's not gold yet, right? So the current situation is companies do like a manual review of, say, 1 to 2% of conversations in QA, quality assurance, or they get surveys, those CSAT surveys where they say give a thumbs up or a thumbs down, or an NPS, how likely are you to recommend this company to someone else? Of course, they have their place, but they're not that meaningful. Those surveys are biased, those surveys are random, and it's very difficult to extract really meaningful insights from them. So what do? We use AI to transform every customer interaction into an opportunity for insights, optimization, and growth. We try to improve the quality of CX conversations using machine learning to make customer support more human, empathetic, and scalable. In essence, we give them the light and the tools in that mine, of that raw resource to extract the gold. And we're touching upon every message, every interaction. You can aggregate it by all the things I'm going to talk about, but you could aggregate it by agent, you could aggregate it by team, you can aggregate it by different contact drivers. You get a tremendous amount of value for CX and insights. And what's really motivating for me is when you can get insights from what's going on in those conversations, and you can push that to other teams, and you can affect your entire company, figure out what's working, what's not working, and how to optimize things. So Loris's approach, basically, the challenge is understanding the domain, right? Like ChatGPT has become totally socialized. You could use all these models. They're in the news every day. LLMs are transforming how people do work, and everybody has access to it. But really, you want to understand the domain and the problems that are happening there, and you need to get the right data, and the right labeled data is really the differentiator. So, out of the box, you can take an LLM and you can extract some insights from it. You could even try to make a chatbot, using it, but we've seen there's been, lots of really, failures there, some bad stories. But our approach is really understanding the domain really well, understanding the conversation phases, understanding the dialogue acts. I'll get into that. It's the role every message is playing in a conversation. We have had the opportunity now, to use proprietary data to optimize models for customer support. So we understand customer sentiment, satisfaction level on the message level. You can see the trajectory of the conversation, how the customer is feeling throughout. What we call conversation markers. It's these moments in conversations that matter. We've developed client-specific contact driver models, and key, really, really, really important, is enabling a feedback loop on how users interact with our product and the predictions of our models. So we've established a system where information about user behavior and outcomes is collected and analyzed and then used to improve the product and the accuracy of our predictions over time. This is key. This is essential for ensuring that the product remains relevant, accurate, and responsive to the needs of users. This is the flywheel, the feedback loop. So you can see it's a combination. It's the best of humans and machines. So our approach is you want to take the best of both, right? Machines don't get tired, but they can't take the insights and view things like a human and use the reasoning and judgment of a human. So if you start in the top right, you have automated voice of the customer. So what does this mean? This is uncovering intents, sentiment, reasons to review, and just seeing like larger trends in customer conversations. It's basically the ability to segment things. And that I'm going to get into that more, but that's just so important. When you have this information, you then can sort of assess things, and you can figure out conversation quality. You can figure out agent quality. We assign a conversation quality score to every single conversation, which is really nice. Also, with this information, if you know the sentiment, if you know what the conversation's about and what the customers are saying, what the agents are doing, you can create a real-time agent assist. That's actually where we started out. So now, like going over now to the other side, you have conversation insights. So taking all of this information and then aggregating it and bubbling it up to the human and allowing them to see and uncover insights, maybe remove some of the friction that they're seeing in the customer journey, enhance their offerings, figure out what the problems are. And then there's post-conversation. So in this, you can do agent coaching, and then you can improve workflows as well. And all in all, like what this is doing, it's giving companies the ability to improve their customer experience, improve their operational efficiency, and get more insights and really make a difference. They're only seeing such a small percentage of things now. We're giving them the ability to see everything. This is the nice GIF that I created. So what it's showing here is towards the end of 2020, we had about 1 million, say, customer service interactions analyzed. And now you can see towards the end of 2023, we had over 200 million. It's a staggering amount of data. It's incredible as a data scientist to have this amount of data to access, to run models on, to make predictions on. We actually closed a couple clients since then, so it's probably a big underestimate, but we're analyzing over 5 million messages per month. And it's much more than just the messages, right? We're making hundreds of predictions per conversation. So it's just an incredible resource. It's like being in data science heaven. This is something that I wanted to talk about. So I talk about these conversations, these interactions that are coming in, but like, so what is it? Is it chat? Is it email? It's all of this. It's omni-channel. It's chat, it's email, it's any of the messaging apps, and it's voice. This is really hard. It's extremely difficult to do all of these channels. We added in voice a year ago. The nice thing, even with all of the problems of voice and transcription and what they call diarization, the ability to segment who's talking and when people are like talking over each other, it's pretty difficult to figure that out. It's still incredible that on the aggregate level, our models work fantastic, like really well, and you're able to extract great insights from it. But this does cause some challenges. This makes things very tricky. Okay, so now getting into the state of machine learning, at least from my perspective. The state of machine learning and AI, it's at this peak hype cycle. It's been there since ChatGPT, the end of 2022, it has not come down. There's hundreds of papers coming out every month. You see new things coming out on LinkedIn every day. The big companies are doing things, startups are doing stuff, and people are making these promises, right? They're making promises that AGI is here, AGI is around the corner. They're lying to you. That's not true. They're telling you that they can eliminate biases, eliminate hallucinations. They're lying. It's not true. Some of these great breakthroughs, some of them are great breakthroughs, but some of them are marginal. Some of them are incremental changes. And just obviously keep an eye on the new things. Keep a pulse on what's happening. But in time, you figure out what matters. You don't always need to try to put that hottest new thing in, the next day. So yeah, the world and the machine learning world in particular has been captivated by generative models and LLMs, and it is for good reason. It's incredible. It's unbelievable what they can do. They're totally revolutionizing the way everyone does work. It's revolutionizing the way that Loris does work as well. But in industry, there is still an enormous amount of value from information extraction. Companies, they just need to be able to classify and categorize their conversations, just understand what's going on. It's a hard problem, but it's not something necessarily that an LLM is necessarily the best thing for it, especially if you're trying to do something in real time. Like GPT-4 with an API call and like a 10-second delay. Claude is even longer latency. They're amazing. They give you great outputs, but they're too heavy for these simpler tasks. What I've been saying with LLMs and generative AI, it's very easy to create a demo with a small amount of data, clear use case, no one's trying to do anything crazy. It's very hard to get something into production, and it's even harder to deliver it at scale. And you don't know all the edge cases until it's out in production, and then it's kind of too late sometimes. And it also can get very expensive at scale. Yeah, it sounds nice. They lowered it by, whatever, it's like 0.001 cents per 1,000 tokens and everything. But on a massive scale, that really can add up. And there's this point where the ease of this approach, it might be tempting, right? But you can run into this issue where what your users want to pay is less than what it costs you to run your service on an LLM. And cost matters. Basically, just because it's the hottest, trendiest thing doesn't mean that you need to do it, doesn't mean that it'll work for industry. And you can see in this meme, machine learning scientists are distracted by generative models, but really information extraction, tried and true, you can get amazing value out of it. And another thing that you can get really good value out of it, this is from 1996, Crisp DM. It's about business understanding, establishing a goal. You need to have an operational goal aligned with business objectives and providing values, understanding your data, preparing your data, modeling, establishing a prediction goal. While you're doing that, you're understanding, exploring, and preparing your data. You sometimes need to fit your data into the type of model that you're doing. While you're doing that, you also need to think about your evaluation, right? Define tangible evaluation metrics for training and deployment as well. Then you train your model. That's the fun part. And then you deploy the model and you apply what's been learned to new cases. It doesn't matter how well your model does on some limited data set that you pulled and extracted. You're looking at a small sample and you're training on it. It only matters how it applies on new cases, unseen things that it hasn't seen before. This is something that I just wanted to take an opportunity to talk about, like the role of data scientists and the role of machine learning engineers. So I view it as that there's three main phases of a product, of a project also. First, you have to do like exploration. So this is tinkering, exploring the data, proof of concept, maybe even some prototype. It's really all about feasibility. I view this as one of the most important things that a data scientist can do, showing other people what's possible. Then data scientists and machine learning engineers do the modeling, right? This involves creating the model, training the data, training the model, getting the right data, tracking experiments, doing the right evaluation. And then, yeah, it's great to have a model in your notebook, but then you have to get it deployed into production. This is where machine learning engineers and ML ops, deploy the model, monitor the model at scale, scale the model. So, it's nice to be able to get like 10 predictions, 100 predictions, but what's going to happen when you're getting 1,000,000 predictions or hundreds of millions of predictions? And then obviously things change, requirements change. How are you going to update the model? And then that's when it kind of gets back into the, data scientists exploring again and understanding how are we going to update, how are we going to keep this model relevant. So now let's go into machine learning and NLP at Loris. So as I was mentioning before, it's really about understanding the domain. Customer service, you could boil it down to three questions. How's the customer feeling? Why did the customer contact the company? And how did the conversation go? And you can view this as this realm of conversation modeling and intelligence. And in that conversation modeling and intelligence, there's a lot that goes into it. There's other models. So you could take how the customer's feeling. Okay, that's a sentiment model. Why did the customer contact the company? Okay, that's an intent or contact driver model, which we're gonna get into in the second part of this conversation. And then how did the conversation go? You can summarize things, you can predict satisfaction, you can predict resolution. And then there's an underlying thing, and it's understanding the role that every message is playing in a conversation. These are called dialogue acts. You can consider them agent actions, you can consider them customer behaviors, agent essence. There's many different terms for this. But basically being able to extract this information, being able to understand conversations, it enables you to do anything that you want to do. You could do real-time agent assist. You could figure out what's the next best action. You can extract insights, and you can do quality assurance. I find dialogue acts to be a super fascinating field. It goes back to speech acts in the 1950s with John Searle. It's like a combination of like philosophy and linguistics and now natural language processing. So talking about Loris, these are some of the models that we've created, we maintain, we improve. So we have on the message level. So what I mean there is like if you're in a chat and every time you press enter for the customer message, we're analyzing a lot of these things. So sentiment, understanding on a 5-point scale from very dissatisfied to very satisfied, how are they feeling? We assign a score to it. Target. So a number is great, but it's only one dimension. So what is that sentiment directed towards? In the customer service domain, we care if it's directed towards the agent that they're talking with, or if it's directed towards the company, right? Is it just like a company policy and there's nothing the agent can really do? This model, conversation markers, so that could be like reasons to review. Is there a regulator threat? Is there explicit frustration? Is the customer expressing confusion? Along with some of those dialogue acts. There's other models too, profanity, polite refusal, question detection, and more that I'm just not listing here. And then there's conversation level. So as I was mentioning, if you have the trajectory of the conversation, you know the sentiment for every message, we calculate this conversation quality score. It's really interesting, right? First, they're only getting 1 to 2% on QA, maybe 10% using that CSAT, the thumbs up, thumbs down at the end of a conversation. Now you're getting a score assigned to basically any eligible conversation. Then we can summarize things. Summarization, like LLMs are great for that. Generative models, it's a task that's good for generative models. Resolution, predicting if the issue has been resolved. And then we have something called agent actions as well. Now getting into one of our custom models. So this is for every client. We've created dozens of these. Basically, it's creating a client-specific text classification model for each client to understand their customer's reason for contact. It's creating a meaningful text classifier for that company because everyone has a different hierarchy. Everyone understands things, a different taxonomy. Everyone understands things in a little bit different way, needs to use it in a different way. I'm going to get that into the next thing. It's really tricky because people call this by many different names. They call it intent. Some people call it topic. Some people call it intent. Some people call it reason for contact, contact driver, submission reason. That's why I just say it's just about creating a meaningful text classifier. It doesn't matter really what you call it. You're just giving them a way to segment their data. But it's really important to understand the underlying need. Why would they use this client-specific model? What do they need it for? They want to know what the conversation's about. They want to understand their company's contact drivers, because knowing the contact driver of conversation allows Loris and our clients to segment into meaningful groups and then help you create some improvement opportunities. It's interpreting what a customer is saying no matter how they say it. So typos, their terminology, not the company terminology. And then it puts you in this position where you can route tickets based off of it. You can analyze trends over time, and then you can also find problematic areas and you can create and improve workflows. So one nice thing here, this is seeing a trend over time. So you see, this is for a subscription service. You see auto renewal and cancel subscription. So this makes sense. You could see on January 1st, there's a spike. February 1st, there's a spike. You can probably guess why. It's because that's when the bill comes. So they're asking about, hey, why I didn't want to auto renew, or hey, I want to cancel my subscription. And it's really validating to see this, right? You create this model that's tagging every incoming message, every incoming ticket, and then you start to see these trends that make sense. Here's another one, order mishap. So you see towards the third week, say December 20th here, January 21st, 22nd. It's like the third week of the month, because for this subscription service, that's when the users get their package. So that's when you're going to have the order mishap. Oh, my box came damaged. I'm missing an item, etc. So when you have these models, it's really important to think, how am I going to evaluate it? So these are some of the metrics that we use. So first off, coverage. What percentage of the tickets are assigned one or more intent? The reason for this you're not going to get 100% coverage. Don't even aim for 100% coverage. Something's wrong if you're covering every single ticket. Like people, there's junk. There's always junk. But you don't want to have 20% either. 20% is too little. So somewhere in like the 70 to 80%, it's a really good place to be. You want to obviously understand precision in some way. So when you do detect an intent, is that prediction correct? And then frequency. The companies know what's happening more often than not. They have a good handle on their problem space. So in historical data, does the frequency of each contact driver make sense? And like what I was showing you before, seeing those spikes for cancel subscription in the beginning of the month, like those are things that make sense. It's very validating. So we do something where we use unsupervised learning to help us do supervised learning. So we do topic modeling to support text classification. So for a moment, I just want to talk about unsupervised learning. So if you look at this image, you could see all these different colored images and shapes, and you want to sort them somehow. So you want to find some structure in the data to highlight what the human should pay attention to. Because data is great, but there's data everywhere. What you need is the labeled data. And getting good labeled data can be expensive. Human annotators, are expensive, and expensive in more than one way. Expensive, obviously, in cost, but expensive in time. It takes a human a lot of time to annotate things. And then you want to put measures in place to improve this process. It's very important. So this is sort of very high level of abstraction, what we're trying to do, where we do unsupervised learning topic modeling for us, and we break it down into known categories. And then instead of saying, so let's use this example, instead of saying, hey, what pile should I put this into? All you're asking when it's in that middle section, is this an orange square? It's a much easier question than like, what color, what shape, doing all of these things, keeping all of these things in your mind. It's much easier to minimize it to a binary question. So you're kind of, by doing this clustering, you figure out what the human should pay attention to. You have a human in the loop, and it's important, as I was saying, you want to maximize the impact of the human's time. Oh, but I do see there's a question that popped up. You're using topic modeling. Isn't it a very old technique? Yes, topic modeling is a very old technique, but that doesn't mean that it's not relevant. LDA, Andrew Ng worked on that back in the beginning of the 2000s. There's this library that I'm going to talk about, BERTopic, which is using the breakthroughs in transformers and contextual embeddings to do incredible things. And you're going to see. But it's a good question. So here's the process. This is what you wish the process was like, that it was this linear thing where you could discover what the topics are. Because that's the first step. You don't even know what the topics are yet, what the classes are. So you need to discover what your intent classes are going to be. Then you have to define them. You build your data set. You have labeled data. You can then train a model. You evaluate your model, and you put it into production. It's never this easy. So let's say it's a cyclic process where you're doing this thing. The thing I add here is just that you're evaluating the model both on the message level and then also on the conversation or ticket level. But that's not true either. It really sometimes looks like this. The steps blend together. Discovery itself, you could be doing many different iterations of topic modeling. There are examples, let's say like when you do error analysis, you see two classes are constantly confused. Should these classes be merged? Like maybe it's not important to differentiate between these two. Or a requirement changes, and after deployment, they take on a new line of business. So you have to be able to adjust the model. You have to be able to always revisit earlier steps. In our sort of pipeline, it looks something like this. So we've been creating these custom models since the end of 2020. Just over time, we've incorporated the new techniques. And towards the end of, say, 2022, for example, we added in that representation layer. So I'll get to that in a second. So you start off, you have, say, hundreds of thousands of messages. You break it down into something manageable, say 20,000. You plug it into this topic generator pipeline where you get contextual embeddings using sentence transformers. You plug those embeddings into BERTopic, which I'm going to get into in a second. Unbelievable library by Martin Grutendorst. I'm going to talk about it more in a second. And then you have this representation layer. So you have these clusters, but what are these clusters about? Then you generate candidate intents, and you have all of your messages, and you assign it to a cluster. And then we use an annotation tool, open source, Argilla, to label some of our data. Okay, so I mentioned it now. So what is BERTopic? It's an incredible library. I've watched it grow over time. It's some of the best documentation, the best visualizations, incredible functionality, just like immense shout out to Martin Grutendorst. It's incredible what he does. It's incredible the speed at which he adds in new things, like a new model will come out and he'll show how it can be used to improve it. A new visualization technique, he'll show how you can incorporate it into BERTopic. I'm going to show an example of that later. So now talking about this process, you have raw unstructured text. You need to add some structure to it. So you can pre-process it, and then you can do a sentence representation. This is a contextual representation. So it's understanding the role that words are playing, like the word duck, for example. Like, is it being used as an animal, or is it being used as like the action to duck, right? And you create a compact numerical representation that can be processed by a computer. You have UMAP. There are other dimensionality reduction, because the problem is you get your sentence transformer model, you have it in 512 length vector, 768, whatever, huge vector. You want to reduce the dimensions, so you could use many things. PCA, TSNE, UMAP is the one that I use. Great library, great documentation. You can check that out. Then you have to do some clustering. So HDB scan, hierarchical density-based clustering. Then you have these clusters. And now the problem is we needed to name these clusters. This is a great place to plug in generative AI and large language models. Hey, take a look at, these 10 messages in these clusters. What would be a great name for it? So it's really nice to be able to do that. So this is the discovery process. I basically touched upon all of these things, but you can leverage many techniques. You could do unsupervised learning, seeded topic modeling, if you know some of the words that matter, generate names for topics, generate definitions. So yeah, like in the end, you're putting in all of these messages that are about all of these different things, and it breaks it down into, cancel subscription or cancel my order, where's my delivery, and also some outlier class. I'm going to get into some visualizations later, but this is an example. Every dot here represents a document. I'll show it better in the demo later. So just to summarize the discovery, this is what you really want. This is what you need. You need to figure out how many classes are there, a number of classes, generate names for the classes, are they meaningful, and then generate definitions for the classes. So if a new message came up, you need to be able to understand, like, does it belong to this class? And then you can get representative samples for each class. And what that does is it gives you samples, like it's part of your definition for what a class is, basically. Then you gather labeled samples. So we might input, say, thousands of examples with their assigned topic, but now with few-shot classification, you need maybe hundreds of labels. You can get subject matter experts and annotators to help you. And then you also need to get additional samples to validate the model. There's a really cool functionality in Argilla that helps us build data sets quickly. This is the Argilla interface. I wish I had like more time. I would pull up the actual Argilla interface, but basically you have this ability, if you include embeddings with your messages, you can find similar. And then you can find like all of these messages that are similar to it. It's a really great feature. It saved our annotators hours. Okay. So now we did our topic modeling, we annotated some data, and we have labeled data. Sometimes we might have more than others, but one of the techniques that we use, one tool in our toolbox, is SetFit. And this is a way of leveraging few-shot classification. So what is SetFit? Efficient few-shot learning with sentence transformers. Sentence Transformer is an incredible library created by Niels Reimers. He was also a guest on my podcast. He was at Hugging Face, and now he's at Cohere. The current maintainer of Sentence Transformer is Tom Arson. Shout out to him, who's now at Hugging Face. And then the SetFit library was a combination between Intel and Hugging Face. Louis Tunstall was the lead author. Shout out to him as well. He was a guest on Learning from Machine Learning. These are just great episodes. You guys should check them out. Niels Reimers as well. And the current maintainer is Tom Arson. So he's crushing it. Basically, what's happening here, you use some existing sentence transformer model, and you have your classes. So you know you have two messages. They're in the same class, so they should be close in space, in the embedding space. And then you have messages that are in different classes, and they should be further away. So that's actually the trick that they do. It's this contrastive learning. You create positive triplets, you create negative triplets, and you do like basically an objective function on that. And I'm going to show it in the demo later, but it brings messages that are similar closer and messages that are different further away. And it creates this fine-tuned embedding that you can then lay a logistic regression model on top. I know I said logistic regression. It's 2024. It's unbelievable. And you can use that as the text classification head and get incredible results. In our pipeline, it looks like this. So continuing from that discovery, and the messages went into Argilla, we got labeled data. And yeah, I just talked about all of this. So generate those pairs, fine-tune that model, encode the sentences, then you train a classification layer, and now you have this SetFit classification model. So like why would you use SetFit? It's fast training and it's fast inference. You can move really quickly. It's representation learning, so it's capturing meaningful relationships among items within your set. It's talking about you're using this contrastive objective function. It's scalable, it's fast, it's being maintained. It's SetFit 1.0 came out a few months ago with great documentation. No prompting required. You don't have to fight with an LLM to try to classify things for you. High performance can be achieved with few examples. It's elegant. So here's your supervised text classifier. You put a new message in, and then you predict on multiple classes. So you can see here, like, I want to end my subscription. You'll cancel subscription with 0.97, and you'll get probabilities. It's really nice. Then you do batch inference, because it's like what I was saying before. It doesn't matter how you're going to do on the training set. You're going to do great. You have to do it on some holdout data set to figure out how you're doing on the message level and on the conversation level. You create a classification report. You do error analysis. One of the really cool things about Argilla is that after you have a model and you make predictions, those probabilities that I was showing you, you can put them as part of your data set, and then you can see next to each prediction, it has the probability for that score, and then you can do really cool things. I mean, you can examine outputs with their probabilities, really gain a great understanding of the performance of your model. And then you have the ability to segment data by probabilities. Let's look at ones that are classified between 0.8 and 100. You can filter by whatever metadata you want, and I'm going to keep saying it. Segmenting the data is important. You need to be able to examine specific parts, examine specific types of errors even. Okay, evaluation reminder. What % of conversations are assigned an intent? Precision, when an intent is predicted, is it correct? Frequency, does the frequency of each contact driver make sense? And this must be evaluated both on the message level and the conversation level. And the challenge, how do you evaluate a model on unseen data if you don't have labels? Like, we did get some labels through topic modeling, and you can leverage topic modeling again, but you want human oversight sometimes, or you could look at aggregate metrics, or you could use an LLM. We do a combination of all of these things. So some of the aggregate metrics, just coverage, right? Like, I'm assigning intent for 75% of conversations. It's a good health metric. The number of intents per conversation. So like, let's say you're assigning 10 intents for a conversation. Something's wrong, right? You're misfiring. So you could see this breakdown here, like 48% is 1 intent per conversation. That's great. 18% or 2, 5.5 or 3. Like, that makes sense, right? In terms of like how many intents, how many things that how many reasons for contact, right? Sometimes there's more than one issue for these conversations. We did research on it. There is usually more than one issue. And then you can also look at class frequency. We've also created this LLM validator. This now has become a real thing. We've been doing this for a while now. It's a generative system that can be used to validate training data and validate predictions. So if you take a prompt, something like this, so remember I was saying how you need to have the name, the definition, and examples. Well, you plug it right into here. Given this class name is defined as that definition with the following examples. Is the following message a member of that class? Yes or no. It's really cool. It helps you do evaluation and thresholding. Due to time, I'm going to gloss over thresholding. It's very important, the art of thresholding. It's extremely important. Okay, before I go into the demo, is it possible? How can I do a question or two here? I'll check the Q&A. How do you improve clustering? Please explain process of clustering. I think I touched upon that. How to get the correct number of clusters and human in the loop. Yeah, you have to analyze and you have to look at the outputs. What I might think is the taxonomy might be different than what the company thinks is the taxonomy. So we'll work with them and we'll see. So say the topic model outputs 40 topics. In actuality, I think there's 100 topics. Sometimes they'll find that maybe some classes can be combined. Sometimes we'll lay other rules on top to separate classes. In actuality, it's a hierarchy, and in actuality, it's a multi-label problem. Improving clustering, you can play around with a lot of the parameters. You can change your embedding model. You can change the number of minimum samples per cluster, just to name two. You can change every component there. You can change your dimensionality reduction, your clustering algorithm, making data for contrastive learning. How do you get positive and negative? Yeah, so you have labeled data, small set of labeled data of positive samples, of each class. So you have class 1, class 2, class 3. Messages that are in class 1, like message 1, message 2, that'll be a positive sample. You take a message from class 1 and class 2, that'll be a negative sample. You create all of those pairs. That's why it's so elegant and it's so beautiful. I'll touch upon some of these other ones as we go. I want to get to the demo, but keep putting questions in, and I'll get to as many as I can. Okay, let's look at topic modeling. So on the left-hand side here, you see the breakdown of this library. I like to just give of this notebook, I like to give just an overview. So topic modeling, obviously you're going to install what you need, the imports. Then you have the data. Let me just show. So for this data, I use Dialog State Tracking Challenge from ACL 2023. They had a nice data set of banking data. We're going to explore the data, run BERTopic. We'll simulate what intent discovery kind of looks like, train a classifier, evaluate a classifier, and visualize what's happening. But let's see how we can do it. Going back to this notebook, we're going to do topic modeling using BERTopic. Installs, imports, you're going to have that data. That's the data that I was just mentioning. BERTopic, you figure out what embedding model you want to use. You define your submodules. So for dimensionality reduction, I'm using UMAP. For clustering, I'm using HDB scan. Then you have that representation layer. You train your topic model and you assign a cluster to the messages. And then I'm going to show some of the cool visualizations that you can create. It's much faster using a GPU. I don't have that many documents here, but you still could. I also, only need BERTopic. OpenAI, you can use any LLM. Just for this demo, I decided to use OpenAI. And then, this really cool visualization tool that I found recently, Data Map Plot. I'll show an example. Imports. Google Colab is amazing. So it has this way you can keep your secret keys here. You can access it, and then you can actually instantiate your client, using that. I'm going to get rid of this so we have more space. Another thing, you can connect your drive directly to Colab, which is really nice. So I have a data folder in here, this DataHour demo that I'm doing. Let's read this CSV. It looks something like this. So you have what conversation, you have the turn, obviously the speaker's customer, that's what we're looking at. You have the utterance, which is the text. These are all where intent is being said. And then you have the intent. So I'll show some point, all the intents. We're going to pretend like we don't have the intents, but in this case we do, which is nice, but we're going to pretend like we don't have intents. So all we really need is just this column here, the utterances, and that's what I'm taking here. Docs, a list of these utterances. In this example, I used a newer model, mixed bread. This one, yeah, check this out. MTEB leaderboard. Yeah, you want to find a model that's like a good size for you, and works in the environment that you're in. Okay, so yeah, we create the embeddings. It's this simple. Embedding model.encode. Put your docs in, a list of documents. For the visualization, I want to reduce the embeddings, so I want it to be two components. I want an X and a Y dimension. You'll see why. For the actual topic modeling, I'll use more components. This is basically the default. These are some of the parameters that you can change, minimum cluster size, minimum samples. You can use different metrics. Here you can use different cluster selection methods. It basically like change. You can read all about these parameters in the HDB scan library. And then this is a really cool thing, and this is relatively recent. Creating this representation layer. And here it is. This is the prompt. So first, I'm going to extract keywords using KeyBERT, another incredible library by Martin Grutendorst, and then OpenAI. And the prompt is, I have a topic that contains the following documents. And then you're going to put a handful of the documents there. The topic is described by the following keywords. You put the KeyBERT keywords that you found, and based on that information, extract a short label in the following format. So let's see, what do we get? We instantiate our topic model with all of those submodules. We train our model, we save it, and then this is the output that we get. So every topic that's seen in this data, and then here's the representation. So it has seen nothing. The only thing that is seen are messages, and it creates unbelievable names for topics. Finding nearby ATMs, finding nearby bank branches, wire transfer requests, closing savings account. It knows nothing about this data. It knows nothing about this data. All we did was cluster it and then ask OpenAI GPT-3.5 to create a potential name, disputing transactions. Like, this is really, I'm always blown away by this. Report stolen credit card. These are good names for intents. I assign each message to its topic with its probability. I don't think we really need it for that. Then we're going to use data map plot. First, I just need to create a mapping so I can get the name for each message. That's what I'm doing here. So I'm taking the topic, number, and the representation. I create a dictionary. Here's that dictionary. Just handle the outlier class, which is the -1 class. And you create a data map plot. So it looks like this. I'll open it up in a new tab. Boom. So here you see, these are all the messages. It shows the clusters, and you get this really beautiful output with all of those names for potential intents. There's a lot of amazing visualizations for BERTopic as well. So there's intertopic distance. I'm just going to gloss over these. There's each message you can see is a dot here, and you can see the clustering. This is interactive. So if you wanted to just look at like two classes, you could do that. Hierarchical clustering, very interesting. Like check account balance and check savings account, those are similar. So they're going to be similar. If you wanted to move up in the hierarchy, you could potentially combine those classes. Then you can see a similarity matrix, how similar different classes are. And then there's some other cool stuff, but I want to show just one other thing, my other notebook. But last thing here, so we're seeing, so since we do have the intents here, we can see the topics that are created. So this is the topic that the BERT topic classified that the messages as, and then you can see the intents per topic. So it's really cool. This is validating as well. Finding nearby ATMs, the top topic here is find ATM. We could look at like another one, close savings account. You have the top one being close bank account. So it's pretty nice. I want to show a little bit of SetFit. I want to show one thing in particular. So this is a notebook on SetFit. I wanted to show that you can train a model with very little data. So I pull in my data here. We have a bunch of samples, but I'm actually only going to take, when I split my training and validation set, I'm just going to take 4 samples for each label. So here, this is my training data. For each of those intents, I just get 4 samples. This is just creating a train set, a val set. I load my sentence transformer model. I create my embeddings. And then before I do anything, this is what that training data looks like. So if you want to visualize what that contrastive learning looks like, I'm going to show you. This is before. Then we train our model. So we're training it here, predict on the training data set. And now this is after. This is the training data. So you can actually see how that contrastive learning worked. It's really elegant. So before, they were kind of overlapping each other. You do see some overlap still, like here, external wire transfer and internal funds transfer. I mean, kind of makes sense that that's probably pretty difficult to differentiate, but it's pretty amazing to see. But as I've been saying, training data is great. You know, it doesn't matter. Let's look at it on the evaluation set. So first off, you can see some of the classification report here. It's performing really well. Yes, there are 2 classes, you know, with a F1 score that's a little bit lower. There's that external wire transfer and internal funds transfer, but overall, it's looking really great. We plot the confusion matrix. We see, okay, yeah, that's where the confusion is. That's where the confusion is. But what I really want to show is this. This is the embedding of the documents before you do the fine-tune embedding. And then this is after. And you can see that there's actually you can probably create real boundaries in between here. And that's why you can lay on top of it just like a very simple model to classify. Okay. So this is that nice visualization. This is showing the training data before fine-tuning. This is after. So before, after. It's pretty cool. I like to see these types of visualizations. This is that confusion matrix. It's just showing it's performing well. And then there's a couple problematic classes, but you know, those things can be handled, maybe laying rules on top of it or an additional classifier or some other way. And then this is the evaluation data before, and that's the evaluation data after. So after the fine-tuning of the embedding, which is pretty cool. So just to conclude, yeah, machine learning code in the model, it's just a small set. There's a huge amount of other things that are happening. There's the data acquisition, pre-processing, hosting the model, monitoring, scaling, analyzing, whole field of ML ops. I have some of the learnings here, just highlight a couple of them. Understanding the problem and the use case deeply is so important. Creating high quality data sets will always help you in the long term. Incorporating heuristics can really help. Yes, the model is one thing, but you're also creating a system. Segmenting data is a must. Threshold tuning is some people don't really pay a lot of attention to it. There's not a lot of resources on it, but it's very important. Especially for multi-class problems. Yeah, you're creating a system, not a model. So you can use whatever techniques you need to get that output for your client. And automation and intent is a great motivation, but you still need to know your data. Visualize your data. Just the process of thinking about how to visualize the data helps you. These were the tools. Yeah, I mean, these are incredible. I talked about most of these. I didn't talk about Spacey or Phoenix, but those are two other great tools or libraries that I use. And okay, so just if you got nothing from today, hopefully now you understand a little bit about Loris. It's just a venomous primate. What it takes to create systems to help companies solve problems. BERTopic is incredible. LLMs are great, but they're just one potential solution, and they're not the only solution. If you're creating a classifier at this point in time, just create a classifier. And combining multiple approaches often yields the best results. So I'll open up to questions. Thank you guys for listening. So I see that there are some questions here. Yeah, I'm gonna try to get those notebooks shared. Definitely the first one. I don't have the links ready, but I'll get them together. Okay, I'm gonna start from the top. So I think I answered this one. I think I answered this one. Thank you. Answered this one. How do you update yourself to current topics in AI? It's a great question. I read a lot. I mean, I keep up on LinkedIn and Twitter. I try not to get too distracted by like everything that's happening. I stay on the I like long form resources as well. Like this book, Designing Machine Learning Systems by Chip Wen. Like this was incredible. You figure out what are the important things in the trends, you know, over time. A lot of things are just incremental changes. You know, they beat some benchmark. Benchmarks don't mean they mean something, but they don't mean that much. Twitter people, yes, Sebastian Roshka, Paige Bailey, the big research, you know, the big names, right? So DeepMind, Hugging Face, yeah, the big ones. How do you have, okay, I got that one. Thank you. Time series analysis for frequency tracking. Yes, we're looking a lot into that. And we're working on anomaly detection and things like that. So I'll say that's answer. I understand sentence transformers generated single vector for a sentence. Due to that, we don't lose minute details of that particular sentence, just a question. That's what it's meant for. That's what sentence transformer is meant for, to represent sentences and to keep as much of the contextual information. The second question there, may distance between two sentences with different meaning get decreased? Does that, yes, so that is something that's very interesting. The sampling approach, you're treating all the classes like the same, while two might be very similar. Yeah, the negative pairs are still the same. The researchers looked at that and they tried to do it. That would be a really interesting continuation of the research of SetFit. It was one of my questions about it too. That's from Ravi. The collab links, yes, I will get that. Okay. All right, awesome. Oh, there's some more questions in. So someone asked, what's the difference between learning ML, DL from a book and from online resource? You use everything that's out there. The number one thing that I did was Andrew Ng's machine learning class. That was like back in 2015 though, but you stay up on it. Deep Learning AI is a really great resource. That's also Andrew Ng. You have to try things, create projects, and do it, and actually apply what you're learning. I think it's important to have a combination of long form resources like books and understand the theory of it, and then also be following along in tutorials. But like just running a notebook that you see is one thing. Apply it to your data. Figure out like what are the little things. Hugging Face is incredible. The resources that they have are amazing. Kieran, thank you for posting links to the podcast. Okay, awesome. I'm looking through there. There are some other questions, but I can't get to all of them. I think we're at time. I appreciate it, guys. Thank you so much. Feel free to reach out on LinkedIn. That's probably the best way to reach me. Yeah, check out my podcast, Learning from Machine Learning. Check out Loris. We're doing some really amazing stuff. Thank you guys so much.
Thanks a lot, Seth. On behalf of Analytics Vidhya, thank you for your time and delivering such a wonderful session. Our audience found it insightful, and we can conduct such more sessions in future with you.
I
I
appreciate
have
it.
already I have already shared your LinkedIn profile so that the audience can get in touch and can get their queries resolved. I hope everyone has filled out the feedback poll. If not, please do so, as your feedback is valuable and helps us conduct more knowledgeable sessions. The recording of the session will be available within 2 days on our community platform. I have already posted the link in the chat section. We will be back with another session of the DataHour on Monday. The links of the upcoming sessions are in the chat section. Till then, bye-bye and keep learning. Thank you once again, Seth, so much.
Appreciate it. Thank you, guys.
Thank you, everyone.